Awesome. Like Adrian said, I'm Eddie. We're here to talk about some cool open source projects that we've been working on at Chainguard. So you can find me on the internet at Eddie Zane, on the Bird site, and then that on Mastodon. If you've migrated yet, we should all migrate, please. I'm coming to you from Denver, Colorado, if you can't tell from my awful butchered English accent. I like to climb big mountains. I'm a software engineer at Chainguard, where we're doing software supply chain security. And I'm a maintainer for the Kubernetes and SigStore projects. So I help lead SigCLI and maintain kube control, and then work on some of the other bits that Luke showed at SigStore yesterday, if you were in the keynote. So we're going to start with building containers. Who here has built a container before? Yeah, quite a few people, as I'd imagine. The problem with building containers right now is it's a very manual and tedious process. You're crafting these bespoke Dockerfiles, and it's a very rigid syntax that you have to abide by. Right, here's the basic Dockerfile for building a Go application. Nothing surprising here, pretty familiar. We pull a public Docker image, do a multi-stage build if you've never seen the multi-stage builds before. And then we pop in the scratch image after we've compiled our Go binary. We have to copy over the SSL certs, and we can copy over our binary and fire it off. So this works as you'd expect. It doesn't take too long to build. So I'll just build that real quick. Right, so it's going to send off the payload to the Docker daemon. I have it cached, so it's going to go pretty quickly. And we can see that that image is how big? It is almost 7 megabytes, 6.5 megabytes. So that's pretty small for a Go binary. But if you were working with a different application where you can't use a scratch image, so if you have a JRE or something baked in, or a Python interpreter, your image is obviously going to be a lot bigger. And you don't know where all those bits are coming from, right? If we run a container scan on this public Golang image, so I'll use Sneak for that. Shout out to the friends at Sneak. Right, so this is going to go test that Golang image for known vulnerabilities and CVEs. There's an update for the payload here. And what you're going to see is, what we got? 105 known vulnerabilities that are in this image. So some of them are low, some of them are high severity. And a lot of this is based on, this image is built from Debian, right? So if I were to run this on an Alpine-based image, there'd be significantly less vulnerabilities that show up on this. And the problem with that is Debian is not known for having the latest updates if you've ever used Debian or Ubuntu before. And these packages are coming from your upstream Debian repository. And they're all funneling into this base image. So as you're compiling your Go application, you're compiling that alongside 105 known vulnerabilities. So out of this Go file, out of this Docker file, the only thing that's really important, the only thing that really matters to building our application is this bit, which is how we compile our Go file. Everything else is boilerplate, right? All of this can be abstracted away. You shouldn't really have to copy and paste this from Dockerfile to Dockerfile. So this is what I like to refer to as bash and duct tape, which is basically all modern CI and CD is made up of bash and duct tape, which is quite bananas. And so the question then is, what else is there out there? So how else can we build containers without writing these bespoke Docker files and managing them manually? So if you're using Go, you've probably heard of Co. Anyone use Co before? A couple folks. So Co can build a Go file without a Docker daemon. It knows how to assemble the tar layers for building this file. It gives you an OCI compatible tarball that you can load into a Docker daemon or ship off to a registry. It is super opinionated when it comes to Go, and it uses something called the distrolist base images. Has anyone used distrolist before? Yeah, quite a few people. Right, so this is great if you're a Go developer. You most likely are using this in your CI environment, which is actually what it's really meant for. Jib. Anyone use Jib? This is a tool by the folks over at Google for building Java images, very similar to how Co works. Same kind of vein of a very specific language tool for building containers. Canico was just mentioned by the previous speaker. Anyone else using Canico? Yeah, same hands. Y'all have experimented with everything, huh? So Canico is for building containers inside of a Kubernetes cluster without a Docker daemon. It works by assembling the tarballs and those layers inside of user space, and then ships off an OCI compatible image. Same kind of deal. Build packs, yep. Quite a few less people, right? So build packs were very popular in the days where Heroku reigned supreme. It's a bunch of bash scripts and duct tape tying it all together, right? Same kind of deal. This works for most of every language. There's pretty much a build pack for whatever language you want out there, and you can write your own if you'd like. It's just a spec for how those files should look. And that leads us to Bazel. Yeah, I hear the groaning. Bazel, folks, anyone use Bazel? Yeah. So Bazel is a build tool made by the folks over at Google. It's a kind of a port of their internal tool called Blaze. Bazel's pretty great to use sometimes. It's really hard to configure, and if you're new and if you're adding new files, it's super complicated. But if you're building an existing project that doesn't have to be touched or maintained, it's pretty great. And so we have a lot of ex-Googlers at Chainguard, and they don't really want to use Bazel. For many reasons. And so instead of using Bazel to build our images, we decided to roll our own OS and our own tools. So introducing Wolfi OS, which you may have heard about. Anyone seen our blog post or release on Wolfi? Anyone using the Wolfi images yet? Oh, we got a few people. That's cool. So Wolfi is a undistro, in these air quotes here. So undistro just means there's no kernel. It's BYOL, bring your own Linux kernel, BYOK. It is pretty much everything you need to run a operating system or container without the kernel, right? Because in a cloud native and container world, you usually have a kernel. You're running on Linux, and you have the Linux kernel behind the scenes. Call this Distroless v2. This was built by the folks who built Distroless 1. Fun fact, Distroless started as a 20% time at Google project by Matt and Dan, who work at Chainguard. And they kind of forgot about it until Kubernetes announced that they were migrating to it. And they're like, oh shit, we should put some effort into this. So Distroless is great if you're using it, but you can actually pretty much just drop in replacement upgrade to the Wolfi images that I'm going to show you. Wolfi works on a rolling release, so we build a new image every day and ship it. So you want to continuously pull these down. We encourage folks to rebuild their container images daily or as you're going along with your build process. It uses the APK package format, which is from Alpine Linux. We'll talk more about that in a second. It ships with SBOMs for all the packages that are built in, which is really cool. If you haven't done SBOMs yet, you will have to at some point. It's declaratively and reproducibly built using two tools we'll take a look at in a second. And it only supports x86 64 right now, but ARM support is coming soon, so you'll be able to use it on your fancy MacBooks. I know, I'm sorry. So the question is, why APK? There's actually a great article down here by Ariadne, who is an Alpine maintainer. So I have a link to the slides at the end and a QR code you can grab, but I highly recommend reading that. It talks a lot about how APK works. The idea is that it's declarative and reproducible. It will not leave the system in a broken state, which I didn't know this. So actually, unlike apt or what's the CentOS one called? Yum, RPM, those kinds of things, right? So when they open the package, they kind of apply and install those files. And if they hit an error, they kind of do a rollback and they try to put the system back in a state and they catalog all those files that go out. APK doesn't work that way. APK works closer to a dependency file. So when you do APK add on a system, it's actually just writing a line to your etc APK world file for the package that should be included, and then it runs the resolver and syncs that. And from doing that resolve process, it can tell, based on the manifest of every single APK package, if there's going to be a conflict. So we'll never transition to a state, and there's no such thing as rollbacks in the world of APK. Which means it's great for declarative pipelines, and it's great for your build pipelines. Because if there's something wrong, it'll just fail, right? It won't try to build a bad container, roll it back. You won't know what the state of the world is. It'll just crash, and you'll get an error about your build. So APK is really cool. I highly recommend you reading that. So take a look at Wolfi real quick. And you might notice something as we scroll through this. As I mentioned, there's no kernel inside of Wolfi. It uses the kernel that's built in. And as we scroll through this, you're just going to notice just a bunch of packages and YAML files that are in here. And that's pretty much what Wolfi is. OS is probably, there was a lot of debate internally about what to call this. We can learn more from Adrian later. But the fact that we call this an OS is it's more of a idea that it has everything you need for your OS, which when you think about what an OS is, it's a package manager, it's a maybe kernel, right? And so we have all the packages that are built into Wolfi. It's just one big repository of packages. And so we can just drop into a Wolfi base image here. And so I'm running a Docker container for Wolfi, and pretty much the only thing that lets you know that this is Wolfi is if we cat out OS release in here, which is going to say that we're running Wolfi. Other than that, it's just what you would expect. If I run uname and we look at my kernel, you're going to see I'm running an Arch Linux kernel because I'm running Arch on my computer, by the way. Sorry, I had to throw that in there. Right, but that's the idea, is that when we look at the etc, I mentioned the APK file in here, APK world, right? This will show you the state of all the packages that are installed, right? So it's got the CA cert bundle and the Wolfi base, which has some other bits that you need. And there's SBOMs for all these packages. Cool. So Wolfi is closer to a package manager than an OS. We could debate this later for sure. And then out of Wolfi, so you could use the Wolfi base for your builds if you want to add in packages. It has a repository that uses the Wolfi base repository, so you can pull packages that we've built, and they have those SBOMs in there. At Chainguard, we ship a set of open source images. These are free for everyone to use, and these are built the same way, and they're continuously updated. We have a bunch of different images that we're building. You can see languages, JDK, all that jazz, Wolfi base. There's some failing. Don't use Ruby, I guess. Right, and so basically what we're saying is that this is a drop-in replacement for distroless. And you can see here, that's the Dockerfile I had earlier, and there's the Wolfi build, right? So we've cut it a bit down. We don't have to copy over. There's SSL certs. The static image here is similar to the from scratch, except it has those SSL certs in there. And that's pretty much it. That's drop-in replacement. So if you're using distroless, we highly recommend you upgrade. These are definitely supported and maintained. We have a huge team of people building them. And just to compare the size, I'm actually going to build this. I'm not sure what it's going to look like. So if we build this as a Wolfi image, so it was 6.65 megabytes before. We'll see what this comes to. Roughly the same, a little bit bigger. I think that's from caching layers too. But yeah, so recommend you upgrade. So that takes us to the cool part, is we're talking about Apko and Melange. So these tools were built to declaratively build these containers and put them together. APK, it's a APK-based OCI image builder. So this is very similar to Co, hence the Co in there as well. It's fully reproducible by default. One of the things with building containers in a reproducible way is you have to fake the timestamp of when the image was built. So we usually set it to the base Unix epoch. So it'll show up as 1970 in all of your container images, which is just a requirement for OCI. It has to have a date in there. And so for it to be reproducible, you have to have the same date every time you build it, or else it will be a different build. It takes care of all that for you. It's a testable. It has all of the build steps, all of those SBOMs that are built in. There's no run statements. It's a super declarative approach where you declare the packages that you want installed. And it results in really small images. And it's super SANIC fast. When we take a look at a demo, you'll see quite how fast it is. This is what an APKO manifest looks like. A lot of this is boilerplate as well. We're trying to, this tool is still not at a 1.0 GA yet, so a lot of this is subject to change. I'm on the camp that we should default and not throw these non-root groups in here. You shouldn't have to specify that unless you want to have a different group ID. Same thing with the package manager at the top. Right now it uses Alpine by default, but I think we should default to Wolfi. So quite a lot of this will be cut out. And then you can see I have a local repository declared and a local package that we're installing. So I mentioned that APKO requires APK packages to be built in, right? Wolfi is entirely APK packaged. How do you take your application and build that into a APK-based package? Well, that's where Melange comes in. So Melange is a builder for APK packages with declarable pipelines. It's multi-build by default for different architectures, which is pretty sweet. You have to specify if you only want specific architectures, it'll try to default to build to everyone. It has signatures built in, so it'll sign all the packages that it creates with whatever keys you specify. And we're working on adding support for SigStore, so it can sign with your OIDC from your pipelines, which is really cool. And Melange may obviously cause expanded consciousness with Baby Spice Melange. Also, this store is around the corner. I thought that was cool. So this is what a Melange manifest looks like. Very similar. We declare the environment on what our build and our process should look like there. So again, specifying Wolfi, I think we should make this the default at some point. These are the base packages that it depends on. The Go package actually pulls in those 3 previous ones, but it's good practice to declare everything that's going into your build, so I have them all listed there. And then we have a pipeline. And so this is where that red box of bash and duct tape comes in. We can't get rid of it, unfortunately. So somewhere along the lines, we have to have this built in. We could replace this with Co if we'd like, and Co could be building this container. But this way, it gets abstracted from actually building your container. So you can package it with this, and when your container gets constructed, it's declaratively. So now let's take a look at how that works, which is the fun part. So you can see my awesome fast speed typing, like Luke did yesterday. So I'm going to run a Docker command. So right now, APK requires the APK tools to be on your system, which means you most likely have to be running Alpine Linux. So we run this in a container for now. We are working on porting APK tools to Go, so you won't have to do this step. It'll be able to run natively on whatever OS you're using. And so this is using a bunch of flags in here, but it's running Melange. I have a pointer somewhere. It's running Melange. We have an SDK container that has all these tools built in, which is what you can use easily for your pipelines. We're building just AMD, and I'm going to say use this packages folder, so it's going to write all my APK packages out there. I have a signing key, all that jazz. Cool. So we run this. It's going to build out my package. You'll see it's pulling in those dependencies that are declared, some transitive, installing GCC, all that jazz. This should only take a minute. And this is kind of network dependent too, so. Cool. So my Melange package was built. That's awesome. It was signed with that signing key. Again, obviously we'd like to sign with SigStore with an OIDC pipeline. We take a look at the tree here. We can see that the package is super small. It's pretty much just a Go binary. And the really cool thing about building APK packages, I don't know if you've ever built a Debian package, but it's one of the most challenging things I've ever done in my life. The documentation is super sparse. There's a bunch of random bash scripts out there that do different things, a bunch of deb helpers. An APK package is we give you a folder that's down here, this targets test dester, and everything you put in there is just a flat layout file for the package. So it'll just be user bin hello server is what the package winds up after it's installed. So I'm a big fan of this. This is how Pacman packages too, which is the Arch Linux package manager. And so we've built that package, and now we can build an APKO container image. You can also say Apko. We don't have an official pronunciation yet. Same kind of deal. So this is running that Docker. The privilege flag here is not because it's using the Docker daemon, it's because it needs bubble wrap to bubble wrap, say, component of Docker to kind of do all the syswall and sandboxing for you. So hopefully we can pull that out at some point. It's using APKO build, same kind of deal, Arch image. It's using that packages folder, which I showed you, keyring, all that jazz, cool. And it's gonna output it to image.tar. So this is super quick, that's done. And there's no caching here. You don't need to cache, it's just building in a package. And so we can load that into our Docker daemon. Super small, 3.812 megabytes. That's because it's very much just the Go binary and those SSL certs it needs. And then we load that up, and hopefully it works. Let's find out. Hey, hello world, cool. So that is APKO and Melange. And so I have more resources for you. Wolfi is an open source project and we're working on governance, so we'd love other people involved besides Chainguard. So go to the Wolfi community repo. We have a community meeting. I think it's every 2 months, 2 weeks now?
Maybe. Yeah,
I think it's like 2 weeks. It's either every week or 2 weeks. But get involved. Open source is awesome. Join us. This is the APKO Melange origin story. Highly recommend you give this a read. The TLDR is that we seriously didn't want to have to use Bazel. So we also have an education website for Chainguard Academy. There's a bunch of cool stuff on here on how to use SigStore, how to use APKO, Melange, Wolfi, so check that out. The QR code on the right here is for a link to the slides. And then on the left here is a link to our newsletter. We do not spam at all. That is like a super strict thing we do not do. So if you want to find out more about the cool stuff we're building, you can scan that one. And thank you for having me. It's been fun to come across the pond, and I'd love to take any questions.
Thank you very much, Eddie. Do we have any questions?
I'll be around after if you want to talk.
I feel like I should ask a question.
But we need, this is like the time, so like I said, this is before GA, and so this is the time for you to tell us all the things that are wrong for how you want to use them in your workload, because again, Chainguard is mostly ex-Googlers, and Googlers like to do things the Googler way. So please let us know what you'd like to see done instead.
I have a question.
Yes.
Why is it called Wolfi?
Why is it called Wolfi? Great question. So the logo kind of gives more to this, which I didn't like the logo at first, but I like it now. So Wolfi is the smallest octopus in the world. And so this is a magnifying glass showing you a zoomed in on the octopus. So Chainguard's mascot is a octopus named Inky, and so we couldn't get the copyrights to Inky, so we named it Wolfi. Trademark.
Is there any other questions? No? Everybody's like hurrying for lunch, I think.
I know. Go eat. But please give it a play. Let us know what you like and don't like. So thanks again.